In today's video, we're doing a head-to-head for the 4080 Super up against AMD's 7900 XTX. I have the reference model cooler AMD sent over for review and the Founders Edition from NVIDIA that they sent over for review. Now, in my reviews, I focus on the newest games and I look at graphics settings that people might actually use, which is sometimes native resolution ultra settings, sometimes you might kick on FSR or DLSS, sometimes you might use frame generation. By the way, AMD did release a driver level frame generation while I was working on testing, and I've done a whole separate video on that if you want my full thoughts, but I will also be including, anytime I use frame generation and AMD doesn't have FSR 3 integrated into it, I will be showing their AFMF results from their driver level frame generation. And if you are watching this video, you're probably thinking about upgrading your GPU, and a lot of people make a huge mistake. They take out the old GPU, put it in the box, stick it in their closet, and it just sits there instead of being used to fund your upgrade. And Jawa.gg is today's sponsor, and follow the link in the pinned comment and or video description to look at the simplest and fastest way to sell your GPU to fund your upgrade. Also, I can get you $10 off your first purchase using code OWEN10. If you haven't taken a look at Jawa, it is an awesome hardware marketplace for PC hardware. There's also pre-built systems, all sorts of cool stuff. Anyway, follow the link, click get an instant offer, and a lot of people are thinking like selling my GPU is going to be a hassle. Well, that's the whole point of their instant offer option. Because again, you can take a picture, list it yourself, set your own price, all of that, but you don't have to. You also don't need to try selling on the local market where you might be like walking around town hoping you don't get mugged while you're carrying your, your expensive GPU hardware and cash and all that. The instant offer at Jawa works like this. 4 simple steps. You tell them your GPU model and condition, and they give you an instant offer. You can then print your free shipping labels, so that shipping price is factored into that offer they're giving you. You mail them the GPU, they inspect it, make sure everything checks out, and most sellers get paid within 1 business day after the part is received. And that's it, that simple. And again, I can get you $10 off your first purchase. Don't forget about that. Follow the link in the pinned comment and video description to use your old hardware to fund your upgrade. Again, we'll hop into the latest testing, and again, I'm focusing on the newest games, at looking at all the different technologies, upscaling, ray tracing, all of that. And let's hop into the benchmarks. I'll give you a ton of final thoughts at the end. We'll kick things off with Alan Wake 2 at 1440p high preset, which is the highest non-ray traced preset. And the 7900 XTX is taking a 5% lead at 85 versus 81, both performing well, although the frame time graph is a bit spikier for the AMD GPU, leading to a 31% lead in the 1% lows for the 4080 Super. Also interesting to note in this game, there is no normal TAA option. You have to go down an FSR or DLSS pathway. So I did choose the option, for each GPU brand, because I think that's how people would play. And I do think the image quality is slightly different, although very close. Maybe slight edge DLSS, a little bit more sparkles, I think, in motion on FSR, but not too big of a deal at the native resolution. Speak of native resolution, 4K high settings are pretty rough here, and the frame time graph on AMD looks very spiky, giving a 61% advantage in the 1% lows to the 4080 Super, although both GPUs almost tied in the averages. But I don't think those frame rates were quite what we would be looking for anyway, so I think going down to the quality resolution scaling makes a lot of sense here. At 4K resolution, upscaling looks pretty good on both GPUs. I'd still say a very minor edge to DLSS, a few little less sparkles and a little more stability in motion. Performance is about tied at 77 and 76, although except for the 1% lows again, we're seeing a big advantage for the 4080 Super. Now, another thing I wanted to look at is in this game, we do have DLSS 3 frame generation. Now, AMD just released a driver update allowing frame generation in any game, and this game doesn't have FSR 3 frame generation. So that's what I'm recording here, but please note that these are not really an equivalent experience. I've done a whole separate video on this topic, and AFMF, because it's not directly integrated into the game, its image quality and frame pacing is not as good. You can't really tell everything in a recorded video like this, but I am just showing this as an option. So there are some differences in frame generation technology, where DLSS 3 has a wider, more games have it integrated directly than FSR 3, but AMD does have the option to do driver level frame generation, where NVIDIA does not. Anyway, let's move on to the game's ray tracing mode. This is one of the standout ray tracing games, and if you kick on RT High at native resolution, the 7900 XTX just falls apart. We're below a 30 FPS average here, whereas the 4080 Super can handle it at 61 FPS average, more than doubling the frame rate, but I'm not sure many people would be buying these GPUs for 1080p anyway. So let's move up to 1440p resolution. And at native 1440p resolution, the 4080 Super is playable in the low 40s, but it's not a great experience. I don't think this is what you'd choose to do. But the 7900 XTX is down at like 17. So again, we are more than doubling the performance, and one of them is definitely playable, and the other one is definitely not playable, even though, again, I don't think this is quite the way you would choose to play on either GPU. I think enabling quality level of upscaling, which I would say image quality advantage to DLSS here, especially with ray reconstruction in the mix. And again, we're doubling the performance on the 4080 Super versus the 7900 XTX. It's 65 versus 32. So I would say this is a very reasonable way to play the game on the 4080 Super, but the 7900 XTX is not really offering a great ray tracing experience here. Now, again, we could kick on DLSS 3 frame generation. And from a 60 FPS baseline, sorry for my noisy kids upstairs, they're playing. Anyway, off a 60 FPS baseline, I think you get a pretty good experience. With driver level frame generation on the left, AMD recommends you have at least a 60 FPS baseline before kicking it on. And really the latency and the image quality looks pretty bad there, even if it does at times bring the frame rate number up to around 60. Now I say at times because in fast motion and camera pans, the driver level frame generation will disable itself if there's too much motion on screen for it to get a good enough interpolation. So again, these are very much not equivalent frame generation technologies, and I don't think AFMF is a good way to bring up a frame rate from in the upper 20s or low 30s. To really give you a good experience. Now, to look at ray tracing here a little more in depth, I thought I'd look at, since we're already not really doing apples to apples comparisons, really the stronger ray tracing performance on the 4080 allows you to either maybe use it when maybe you wouldn't on the 7900 XTX, or to use less or no upscaling versus more aggressive upscaling if you were trying to use it on the 7900 XTX. So that's what we're seeing here, and I think in the image quality, although YouTube compression kills a lot of it, you can see performance mode upscaling on the left leaves things looking pretty fuzzy, whereas the 4080 Super could choose between native resolution in the 40-ish range or getting, that 60 FPS experience with DLSS quality, which is still a 960p internal resolution and looks significantly better than the performance mode upscaling we're seeing on the left. And the native resolution 4080 image was running at a similar frame rate to the performance mode upscaling on the XTX. But anyway, what about 4K resolution? Well, in this case, you'd want to go to performance mode upscaling for either GPU, and even the 4080 Super's not giving you a 60 FPS experience here, although the DLSS and performance mode does look significantly less, sparkly and more detailed than the FSR implementation there. Now, again, off a 50 FPS baseline, DLSS 3 is something you might consider using. The PC latency goes up pretty badly, to be honest, but this is a pretty slow-paced game. Now, AFMF at this resolution off of a pretty low base frame rate, we're getting a lot of micro stutters, and I don't think the image quality is great. But again, I am showing AMD's available frame generation option when I'm showing the available DLSS option. I think you'll notice as objects are disoccluded, like if you look at things as the character moves past them or the arm swings on the left-hand side of the screen, things are not looking that great, and you can see the frame rate dipping at times where the frame generation feature kind of gives up. But again, even on the right-hand side, I'm not sure I'd be using frame generation with DLSS here either. Some people will be more or less sensitive to that. But let's move on to an AMD-sponsored title. So Avatar: Frontiers of Pandora, despite being AMD-sponsored, is a ray tracing title, and there's no way to turn it off. Every setting in the game does use at least some, some ray tracing. So anyway, at 1080p Ultra, probably not the resolution most people are buying these GPUs for. We're seeing a 24% lead for the 4080 Super at 123 FPS versus 99. If we move up to 1440p Ultra, we're seeing 87 FPS average versus 75, so the 7900 XTX closes a bit of the gap, giving the 4080 Super a 16% lead in the averages, although the 1% lows are 72 versus 56, so a more noticeable 29% lead there in the 1% lows. Although, it's still a pretty good experience here on both GPUs. But in a first-person shooter, you might be searching for that more like 100 FPS type experience. And if you kick on quality level upscaling, if you look at the fencing in the distances and things like that, especially the distant fence lines, they're a lot more stable in the DLSS image, but the FSR image here is certainly acceptable. And we're getting 128 FPS average versus 101, which is a 27% advantage for the 4080 Super in the averages and a 32% advantage in the 1% lows. Now, this is a game that actually doesn't feature DLSS 3 frame generation, but does feature FSR 3 frame generation. And it seems to apply differently to each GPU. Despite having VSync turned off, on the AMD GPU, it seems to automatically enable with frame generation enabled, but not on the NVIDIA GPU. And NVIDIA GPUs can also use FSR and their frame generation, so we're seeing that here. But I can't really give you a numbers difference there since we're capped to my 120 FPS 1440p capture. So there it is. We could move down to the high settings if you want to get closer to that 100 FPS experience without using upscaling. And I was also curious if turning down the settings, sometimes AMD scales better with lower ray tracing and things like that, but we're still seeing a 21% advantage for the 4080 Super at 114 versus 94. Now, if we move on to 4K Ultra, we're seeing 47 FPS versus 42 in the averages, which is a 12% advantage for the 4080 Super, so the XTX is closing the gap a bit here at the higher resolution. However, I don't think we're hitting frame rate numbers that most people would be targeting for a first-person shooter. So I think at 4K resolution, it's often an optimal choice to use at least quality level upscaling, because with that high of a pixel count, still usually looks quite good for both FSR and DLSS. Although again, if you look at little details in the fence lines and things like that, I do think the DLSS image is a little bit more stable. If we look at the numbers now, the 4080 Super pulls ahead by 18% at 77 versus 65 and 27% in the 1% lows at 66 versus 52. Both of them are definitely playable there, although again I was curious if we went down to high settings, what the performance gap would look like there. At high settings, native resolution, no upscaling, we are seeing 63 FPS versus 56, which is a 13% advantage for the 4080 Super. So they're both kind of hugging that 60 FPS average, but one a little bit below, one a little bit above, although the 1% lows are 55 versus 45, giving a 22% advantage to the 4080 Super. But again, I don't think that's quite the frame rate numbers you'd be looking for in a first-person shooter. So I would probably kick on quality level upscaling, and at the high settings with quality level upscaling, we're now hitting 80 FPS on the XTX and 100 FPS average on the 4080 Super, giving it a 25% lead over the 7900 XTX. And a 38% advantage in the 1% lows at 83 versus 60. But I think that's enough Avatar. Since we're already kind of doing some ray tracing testing, let's finish that out by looking at some lighter ray tracing workloads. Our E-Engine games tend to have some ray tracing, but not real heavy effects, where AMD tends to perform closer to NVIDIA than in the really heavy ray tracing titles. And here at 1080p max settings, which does have ray trace reflections, we're seeing 4080 Super 15% ahead, although both GPUs have an extremely high frame rate. Moving up to 1440p max settings, the XTX closes to within 12% of the 4080 Super in the averages. 20% advantage in the 1% lows for the 4080 Super though, although both GPUs again are performing great. I don't think you would have any trouble playing the game at 157 FPS average or 140 FPS average. So very good experience here in this engine with the light ray tracing workload. And at moving up to 4K resolution, we now see the XTX matching the 4080 Super at 95 FPS, although the 4080 Super still manages to squeak out a 4% lead in the 1% lows at 87 versus 84. Interestingly, the XTX is reporting VRAM usage and allocation over 16 gigabytes, although whether it actually needs that or the engine is just choosing to grab it since it's there is up for debate. The performance was looking good on both. Now, to close out our ray tracing testing, let's take a look at path tracing mode in Cyberpunk. At 1080p resolution, RT Overdrive, no upscaling, we are seeing an 80% lead for the 4080 Super at 54 versus 30. Probably not the way you'd want to play it at 1080p on either GPU, to be honest, because 54 FPS isn't that great, and 30 is definitely not. But honestly, you're probably buying these GPUs for at least 1440p, in which case you'd kick on quality level upscaling to get decent performance on the 4080 Super, where we are seeing 66 FPS average versus 35 on the XTX, which is an 89% advantage in the averages, and basically doubling the 1% lows at 57 versus 29, and an image quality advantage for DLSS, looking a little bit more stable, especially in the temporal stability and the distant details. Now, what about frame generation? With a 60-ish FPS baseline, I think DLSS 3 frame generation makes a lot of sense, and this game does have it. There is no FSR 3 in this game yet, although developers have promised that it is coming at some point, and there are some mods and things like that. But if we use the driver level frame generation on the XTX, watch as we go through these doors here. If you watch the frame rate counter and the it kind of dips as you round the corner, and we saw the micro stutter rate increase for a second. That's where the AFMF kind of gives up, and that's even in the slow, steady camera pan of the built-in benchmark. In actual movement, aiming, and things like that, you're going to see the AFMF kind of giving up a bit at times at these low frame rates. So I don't think, even though you're seeing like a 60-ish FPS number, it's not going to feel or look like a 60 FPS experience. So just keep that in mind, but I am showing the results. Anyway, at 4K resolution, even the 4080 Super is going to fall under 60 FPS, even with performance mode upscaling, which, on the DLSS side does look better than the performance mode upscaling from AMD on the left, and the AMD GPU is at 29 FPS, 53 versus 29. It's an 83% lead, although still not a very high refresh rate experience. So again, you could try kicking on frame generation. The DLSS 3 frame generation, again, being integrated into the game, is going to, and coming from a higher base frame rate, is going to look and feel better than the AFMF from a really low base frame rate on the left. But this is still a pretty low base frame rate, honestly, for the 4080 Super as well. People more sensitive to latency would probably maybe not use it at this point, but people less sensitive to latency or maybe playing on a controller would probably be fine with it. I've seen a lot of mixed reactions to what base frame rate is enough for DLSS 3 to make sense. I would say we're definitely below the point where AFMF makes a lot of sense, at least in my testing, although, reading through my comment sections, some people seem to be fine with it at low base frame rate. So, I'm showing the available option here, but again, my personal preference would certainly be to not use AFMF at that low of a base frame rate. Let's move on to some non-ray traced testing with Starfield at 1440p Ultra settings. At 1080p, we're just completely CPU limited, basically, in New Atlantis. So at 1440p Ultra, we're seeing 93 FPS versus 88 on the averages, giving a small lead to the 7900 XTX. And they're both getting really high frame rates, so I don't see the need for any upscaling or anything like that. If we move up to 4K Ultra settings, we're now seeing 64 FPS on the XTX versus 60 on the 4080 Super, so a 7% advantage for the XTX. And the 1% lows are a 4% advantage. So a small win here for the XTX. Although, and this is definitely playable. I think in a first-person shooter style game, A lot of people would be shooting for more in that 80 to 100 FPS range. So if you do kick on quality level upscaling, it helps move us in that direction. We're now seeing 84 FPS versus 80, so 5% lead for the XTX, although I would say small image quality advantage for DLSS. Although at 4K resolution, the FSR quality does look pretty good here. It's certainly acceptable, and a bit of a 1% lows advantage to the 4080 Super. In Baldur's Gate 3, 1080p and 1440p are entirely CPU limited in Act 3. But if we move up to 4K resolution, we're not CPU limited, but we are seeing very similar performance on both GPUs. A 9% advantage in the 1% lows for our XTX. But a 2% advantage for the 4080 Super in the averages. I would really pretty much just call this a tie and say they both do a great job in Baldur's Gate 3. What about Call of Duty Modern Warfare 3? Interestingly, they're performing very similar in the averages at 1080p, both hitting about 350 FPS, but the 1% lows are significantly higher on our 4080 Super, which is interesting. It's actually taking a 55% advantage. Now, they're both still good. It's 246 versus 159, but that is a noticeable advantage. If we move up to 1440p resolution, again, average performance, they're still basically tied, although the XTX takes a 4% lead now at 293 versus 282. But the 7900 XTX, its 1% lows have stayed about the same at 157 here as they were at 1080p. But the 4080 Supers have moved down to 201, showing a 28% advantage now in the 1% lows for the 4080 Super. Then, as we move to 4K resolution, it looks like whatever was the hang-up stopping the 7900 XTX's 1% lows from going beyond 150 is now kind of not a bottleneck anymore, whatever that was, because now it's leading in the 1% lows at 128 versus 116, which is a 10% advantage there, and an 8% advantage in the averages at 195 versus 180. So kind of interesting results there in those 1% lows. Let's move on to Lords of the Fallen. This is an Unreal Engine 5 game, and it's the most demanding one that I've tested. It's also seemed to be a bit more NVIDIA-sided than the other Unreal Engine games I've tested so far, Unreal Engine 5 games I've tested so far. At 1080p resolution, we're getting 89 versus 94 average, so 6% lead for the 4080 Super. In the averages, although a 4% lead in the 1% lows for the XTX, and that's mostly traversal stutter related with the as you round corners, watch the frame time graph spike as it loads into a new area. At 1440p Ultra, this is a demanding game. Even GPUs of this caliber are hitting 66 and 71 respectively. 8% advantage for the 4080 Super, and the 1% lows are tied on both GPUs at 55. So this is certainly absolutely playable, but a lot of people are buying these types of GPUs for a high refresh rate experience, and Unreal Engine 5 boosts performance a lot based on lowering the resolution. So using upscaling lowers the resolution internally, and now we're seeing frame rate numbers bump to 95 and 103 respectively, 8% advantage to the 4080 Super, and small image quality advantage to the DLSS upscaling, especially as the character moves and things like that, and objects become disoccluded. It looks a little more put together, less sparkly, and a little more stable. If we move up to 4K Ultra, neither GPU is doing that great. We're seeing 41 FPS on the 4080 Super and 37 on the XTX. That's giving the 4080 a 11% advantage in the averages and a 3% advantage in the 1% lows, which is just 1 FPS. It's 33 versus 32. And quite frankly, I think most people would tweak something here to get higher frame rates. And one option is turning on upscaling. So if we kick on upscaling at the quality setting, we now jump over 60 FPS on both GPUs, 62 on the XTX, but the 4080 Super does jump to 71, giving it a 15% lead in the average frame rate, 6% lead in the 1% lows, and slightly better image quality, especially again in motion and in the fine details, although again, both look very good at 4K quality settings. Let's look at one more Unreal Engine 5 game, and since we looked at one that was a bit more NVIDIA leaning, I've selected Immortals of Aveum as a bit more of a AMD leaning Unreal Engine 5 title. And this is also one where we can look at DLSS 3 and FSR 3 again. Here we're seeing a 14% advantage for the XTX at 1440p Ultra at 97 versus 85, and a 27% lead in the 1% lows at 81 versus 64. And those frame rates were high enough that I don't think we need to look at upscaling or turning anything down. So let's take a look at 4K Ultra. Well, now we're only getting 52 and 46 respectively, which is a 13% advantage for the XTX and a 14% advantage in the 1% lows at 42 versus 37. However, in a first-person shooter style game, I don't think most people are aiming for, mid 40s to low 50s in the frame rates. So what if we kick on quality level upscaling? And sure enough, we see Unreal Engine 5 boost frame rates significantly by doing that. We're jumping up to 82 and 77 now respectively, which gives a 6% advantage to the XTX and a 13% advantage in the 1% lows at 69, nice, versus 61. And again, small image quality advantage to the DLSS upscale in this game. Now, this is a game that features both FSR 3 and DLSS 3 frame generation, although it was an earlier FSR 3 implementation, which had a bit more issues with things like variable refresh rate support. Now, I'm not going to directly, frame generation, I don't like using it as like a benchmark number for relative performance, especially when they're using different frame generation technologies that have different pros and cons to frame pacing and things like that. If you do look at the numbers, you get a higher average on the XTX with FSR 3, but a lower 1% low result. And the 4080 Super takes a lower average, but a higher 1% low. And there's differences in frame pacing between the two techs. Let's pop out for some final thoughts. So my main conclusion here is that I think AMD is going to have to lower the price of the 7900 XTX, assuming the 4080 Super actually is selling, available in quantity at its $999 MSRP. Now, why is that? Well, first of all, the 4080 Super really hasn't changed anything compared to the 4080 non-Super. I'm actually also working on that comparison video, but I thought it was extremely boring. So I'm going through and I'm adding in the 4090. And if you're watching this video as of the time of, release date for this GPU, expect this comparison with the 4080 and the 4090 coming out within a day, possibly even the same day. But it's 1 to 3% performance uplift in most situations. It's so close that you have to be extremely careful on your benchmark runs, that just the 1 to 2% margin of error, variance when doing a benchmark run can sometimes be the difference between the 4080 Super and the 4080 non-Super. It's basically the same GPU. Effectively, all we're seeing here is a price cut. The 4080 is getting a $200 price cut to its MSRP. So what does that mean? Well, if we look into pricing right now, the 7900 XTX has officially the same MSRP now as the 4080 Super, $999. On the actual market, the 7900 XTX has been $950 and up for a while now. The 4080 non-Super has been at a $1,200 MSRP and been available for around $1,160 or $1,200 for a while now. Now, both GPUs were available for less money a number of months ago, but ever since the 4090 pricing skyrocketed, these have kind of crept up as well. But the point is, I think AMD could get away with a $200 price gap between these GPUs. There was definitely a reason to look into getting that when there's a $200 price gap. But if the 4080 Super really is available at $1,000, then okay, is there an argument for getting the 7900 XTX at $950? And I've really got to say, I don't think so. It does have 8 gigabytes more VRAM at 24 versus 16. So if you have some sort of professional use case where that's relevant, perhaps that's a selling point difference for you. But in actual gaming workloads, 16 should be fine for quite a while. I don't think we'll be seeing that become a major problem anytime soon. So more VRAM is only helpful if you're running out, if you were running out, and I think 16's fine. So with that in mind, then when you actually look at the comparison between the GPUs, yes, the 7900 XTX is often a few percent faster when you're not ray tracing. But it's not a meaningfully different experience. We're not seeing it 20 or 30% faster when you're not ray tracing. I'm seeing oftentimes 5 to 10% faster when you're not ray tracing, and sometimes tied or sometimes actually losing depending on the title. But I would say on average, the 7900 XTX is still a little tiny bit faster when you're not ray tracing than the 4080 Super. But the thing is, there's other feature set differences, right? So one feature set difference is upscaling. And again, at 4K resolution, FSR quality looks pretty good. DLSS does look slightly better. And, you know, you're not going to be upscaling all the time with GPUs these powerful, but you certainly, I think, will be at times. Especially we've seen with like Unreal Engine 5 games that's performance scales so dramatically with rendering resolution that I think oftentimes you would be ending up kicking on at least quality level upscaling. So again, where the upscaler for NVIDIA does have an advantage. And then there are the people who are interested in playing the latest graphically demanding AAA games, which will often feature ray tracing. We've even seen games like, let's go with Avatar, for example. So Avatar Frontiers of Pandora is an AMD-sponsored title. And it runs on consoles, and it runs well on consoles, which are AMD hardware. But it runs with ray tracing at all times. You cannot turn it off. And while I don't think this is going to be super common like right now, I think as technology moves forward, this type of game design may become more common. Now, in the more console-optimized ray tracing titles, the 4080 Super doesn't take a dramatic lead, but it does take a noticeable lead. And then you have the more, basically NVIDIA-funded ray tracing experiences, like the path tracing modes in Cyberpunk and Alan Wake 2. And these, admittedly, are probably going to be a little more few and far between. They're not going to be, I don't think, just popping out every month some new big path tracing title because, again, with developers targeting consoles, I think frequently developers wouldn't choose to implement this level of ray tracing unless NVIDIA goes in there for the assist. That being said, it does end up providing the best looking PC graphics that we have seen, and in some games already that I think are quite good. Alan Wake 2 is probably my second favorite game of last year besides Baldur's Gate 3. Now, that being said, I grew up as a kid watching The X-Files, and I love Twin Peaks and things like that, so this is definitely a game up my alley. I understand maybe it's not yours, but it's a good game, it looks excellent, and here's the meaningful thing. In lower pricing tiers, if you watch my like best GPUs to buy videos, I'm almost constantly recommending you buy AMD up to a certain price point because that's up to a certain performance point. Better ray tracing performance relatively is irrelevant if the better performing product isn't strong enough to make it an experience you would choose to use. Okay, so at the lower performance tiers, I think NVIDIA's ray tracing advantage is not nearly as relevant or big of a selling point. But once you're discussing GPUs with the ray tracing performance of a 4080 Super, it does become relevant because the 4080 Super with DLSS quality, with ray reconstruction, which helps out with the image quality, is able to deliver a maxed out path tracing experience at 1440p with DLSS quality of over 65 frames, over 60 frames per second. Which then gives you a decent baseline to use frame generation if you want to. But the point is, even without that, you're getting a decent experience. This is a meaningful advantage when it enables an experience you might choose to use. That's what I'm trying to say. So how much you care about that is totally up to you. But when you're basically saying that we get roughly equivalent, rasterized performance with a small lead for AMD, a bit more VRAM, where it's unclear if that will be a meaningful advantage in the lifespan of these GPUs. I think it's definitely worth spending more money on the 4080 Super. And if the price gap is only $50, if we're talking $950 versus $999, then I think yeah, the 4080 Super is absolutely the one to pick. In which case, I think AMD needs to drop the price. Now, that hasn't happened as of the time I'm filming, which is Sunday night, and you'll watch this video, I think, Wednesday morning, because it was going to go up Tuesday morning, but NVIDIA delayed by a day. They said, I forget why, whatever. Anyway, the point is, that's when you're seeing it. So as of now, $950 is the lowest price. But here's the interesting thing. $950 is the lowest price I'm seeing available today, but it's not the lowest pricing history. If I just randomly click on one of these, like I did here, it's sure enough, this GPU has been available as low as $889.99. Now, that was back in, it looks like, October. So the point is, like, better pricing has been available on these. They've been creeping back up. So what price point should the XTX hit to kind of make sense? I think it needs to be honestly, I think it needs to be more than $100 less expensive than the 4080 Super for people to be worth considering. And I think it needs to start getting into competition with the step down, the 4070 Ti Super. And so I'm not saying it needs to be less expensive than the 4070 Ti Super, but, you know, what if we were down around that $850 price point? Now, I think you're starting to get the argument that it's, you know, it's not competing with the 4080 Super. It costs a lot less, right? Remember that before the 4080 Super launch, at $950, it cost about $200 less than the 4080, which again is basically the same thing as a 4080 Super, right? There was a $200 price gap. And I think moving back into a $200-ish price gap is probably where it needs to be. And like I said, it has been a lot less than it is now. So what I'm hoping comes out of all of this is that pricing at the high end gets pushed down. And hopefully that has a trickle-down effect on the product tiers below it, and we start to get everything pushing down. But we'll have to see what actually happens. The other thing that could happen is the 4080 Super just ends up on the actual market not costing $999, in which case, then maybe we got absolutely nothing, because the only thing the 4080 Super has over the 4080 is a price cut. So anyway, stay tuned for this 4080 Super 4090 video. And if you were interested in some of that AFMF driver level frame generation that I mentioned briefly in today's video, you can check out my dedicated video on that topic if you're interested. And again, don't forget to fund your upgrade by selling your old GPU at today's sponsor, Jawa.gg, following that link in the video description and or pinned comment, and getting that $10 off your first purchase. Also, a huge thank you to viewers, subscribers, and channel members who have clicked the join button to directly support the channel financially. That is absolutely amazing. When I'm running all of these tests and benchmarks, it can be a big motivation to know that people really value all the comparisons that I'm doing here and that workload. So yeah, the people who have clicked the join button to support the channel financially, huge thank you. And I totally understand that not everybody is in a financial position to do that. So that is totally okay. Huge thank you to subscribers and viewers as well, commenters, all of that. And I hope everyone has an excellent day.